You have a battery source. Just draw a battery source. Okay. You have to have a fuse for that battery source. Remember, we need to protect that wire. So this is your battery source. Okay, and there's a fuse someplace in this circuit, and there's that symbol for the fuse. So you're going to draw from the battery, you're going to draw a fuse, and it's going to go to the key switch. That circuit's fused. Now, some circuits will also have another circuit that's fused here. So you would have a connection that has a higher gauge wire because we're feeding two circuits here. So you can also put a fuse on this side of the circuit for the key switch. Then coming out of the key switch, we have this wire that goes to which terminal on the relay? Hint, the pull-in coil. We then have the other side of the pull-in coil, which is this wire, which comes out and it goes to ground. This is a ground. So there's those two wires. That's the pull-in coil side. Now we have two more wires. One wire comes from a fuse. Here's our fuse. So we have a power supply, we have a fuse, and then you're going to come out of the fuse, you're going to go into the relay, you're going to go through the relay, and you're going to come out the other terminal, which is this one, that's going to go down to the solenoid. And then the solenoid is also a pull-in coil. So if you wanted to draw the solenoid at the end of this wire coming out, and I'll just bring that over here, then you could draw another coil of wire and a ground. And that is the starter solenoid. So that's the end of the circuit. You have a parallel circuit here, and I want to make sure that you draw a parallel circuit. So you have battery power comes up and it branches off to two parallel circuits. So go ahead and draw that, and then make it neat, make it parallel. You know, battery at the bottom comes up, have a fuse, have another fuse, goes to the key switch, comes out of the key switch, goes to the relay, goes to the solenoid. Don't make it look like this. This is spaghetti, and I did this on purpose so it was harder for you to trace it out. But I just walked you through it, so I want to make sure that you can actually draw this, okay? Don't forget your fuses. You can add another fuse even here if you wanted to add another fuse here, or you could add a fuse on this side of the key switch. Because you have changed the diameter, this diameter would be larger because we're feeding two branch circuits, right? So draw that out, and that's what you're going to submit for your lab. So you're going to submit the things we talked about, some diagnostics, all right, some voltage drop tests, and then the drawing of this diagram. Okay. If you have any questions, all right, just email me. I'm going to have you take the whole weekend and do this. And then next Wednesday, I'll have you email it to me by next Wednesday, or even next Thursday for lab. But I want to make sure that you can draw this and you can comprehend that it is a branch circuit. If you're having troubles drawing it, draw me what you have and email it to me. I can make corrections on it and I'll email it back to you. That's easy if you get lost doing this, okay? Oh, one last thing I wanted to go over before I turn this over. I wanted you to notice that what I did here was I took the load device off. I took the circuit from the starter solenoid and I took it off. And I wanted you to be able to hear this. It's pretty quiet out and it's pretty quiet in here. So this is a switch. It's going to close and you should be able to hear it. You couldn't hear it with a switch that I had because the switch made a clicking sound, but the key switch is pretty quiet. So if the relay works, you should hear it go click. So here we go. So that's that little faint click that you can hear. If there's a lot of background noise, you usually can't hear it. And another little trick you can do is to put your finger on it and energize it. and you'll feel it through your finger. Okay, so that's the noise that you can hear, that click sound. If it is hooked up to the load device, which is the solenoid, I want to make sure I put it on the right wire, because if I put it on that wire is constant power. We don't want to do that, do we? That's 87A. That's an arc. That's an awesome arc too. So good. Very cool. That works.